Okay, so the plan right now is to do at least 2 homeworks for this chapter. I want to post the first homework this week. I'll probably have it up on Thursday. 1, 2, 3, 4, 5. This would be homework 6. Then we'll have it due next week on Thursday, or maybe next week on Saturday. Okay, so first, we're going to talk about a loop. So again, sorry, I'm reading from my screen. A edge that connects a vertex with itself is called a loop. Okay, so remember that the vertex is one dot, and vertices are a couple of dots. And the edge is the line that goes from one dot to another dot. So if you go from, let's call this dot A, and loop back to A, that's a loop. Okay, in this example, let's go ahead and write down what the vertex is and what the edge is. So this is okay, the vertex is the dot, which we called A. The edge is going to be AA, so A next to A. Cool. Let's do another one. So the graph is a triangle, and there's going to be a loop off the side. So here, there, back, and then we're going to loop. Goes X, Y, Z. We're going to list the vertices and edges. Vertices are the dots, X, Y, and Z, or Z, Y, X. I'm going to start here. We've got edge ZY, ZX. We just did YZ, it's that one. YX needs to be listed. Okay, and then that's XY, which we already have. X goes to X. So we have an edge XX. then X back to Z, which is right there. So 1, 2, 3, 4 edges. 1, 2, 3, 4. It's at least as many edges as we have in the numbered in the list. Okay, let's do one more definition and then tons of examples. Okay, edges that appear more than once are called multiple edges. So it helps to do an example. Let's draw the next graph. Okay, this graph
is Professor are like in the loops, like for an example for the loop, would a loop be considered to have multiple edges because the X or whatever the vertex in this loop is seen 2 times? Would that be considered a multiple edged entity?
Not quite. Like you could have loops make multiple edges, but a loop by itself is not a multiple edge. I know what you're talking. I kind of know what you mean, but the picture or graph is going to help. So what my picture.
I was just about to say that too. The example will show. Will probably answer my question too. Thank you though.
Cool. And I might make a graph that would work for what you mentioned. So we're gonna start here though. Swoop. This one's gonna go straight over and we'll swoop this way. And we're gonna go like this. Like this. I labeled this Q. It's next to R, then S. D. Vertices. Okay, so list all of the dots. They don't need to be in order. Just make sure each one's in the list. And then we'll go left to right. So, wait, this is the right side, right to left. Q to R. R to S, and then you can also list RS and one more RS. So that occurs 3 times. And then go ST. So it's this part here. Those are my multiple edges. Or, these ones.
So they have to be separated in that sense. Like, do you remember, Professor, on the example that we had? What was it? Probably yeah, it was Thursday. Where I had asked where it was like the X one, but you never made never went all the way through. Like say, the lines have to be separated to have multiple edges, right? You can't treat a multiple edge as one line with like 3 points on it, right? Because
Yeah,
an edge only has to have like 2 points, right?
yeah. One point to the other point, and then it happens again between those same points. And then again, like a couple times. I'm gonna try to draw one that has loops and multiple edges and see how that looks. And by the way, this one doesn't have any loops, just that part right there. Okay. Let's go here and straight through there, and let's loop and loop, loop again. And what's that? Maybe. Okay. Graph. Let's put one more here, right there. Okay, vertices and edges. Okay, AB are the dots that we have labeled. We have AB, AB, which would be multiple edges. And then we have multiple edges as also loops. So there's BB, BB, and another one. 3 times. So I guess these are loops and multiple edges. I think there's one more thing to say, and then we'll do a lot of examples for the rest of class. So if a graph has no loops or multiple edges, then it is a simple graph. Okay, I think we're okay to go on.
Professor, what is that opposed to? Like what it other like the ones with multiple edges? Do you just call it like a graph with multiple edges, or are they called complex graphs, or is there really no determination?
I think a graph with multiple edges makes more sense. I haven't heard any fancy words for non-simple graphs. But I think it might come up later when we get to theorems. Like we're going to find out that there are a few rules as long as we meet some conditions. One of those conditions might be like, is if you have a simple graph and maybe something, 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 then you can use a result. That's kind of a guess. I guess I will reach for the book really fast to peek at that part, but we'll come back and just work through examples. And as far as I remember, I don't have questions on homework about like, is this a simple graph or not? More of like, are there any loops or what are the multiple edges? Those kinds of questions. Okay, one sec. back with the book. Okay, too far. Okay. As a side note, we may use a little bit of information from chapter 6 if there's some time, but I think that those results are in that chapter. Let's just see. Getting sidetracked. So let's focus in on 6.2. Okay, so soon we're going to talk about a connected graph, and that is what we'll need for some theorems that we'll use later on. I guess the focus here really is on loops or being able to spot multiple edges. But I think a lot of the graphs we'll work on will be simple graphs. That's all. Okay, first example. It looks like this. We have a dot labeled E, goes to F twice. And then over here is G. And connect. And connect. So we're going to list the vertices and edges. E, F, and G are our dots. We have EF and also EF. And EG. Last one would be FG. So again, multiple edges, EF and EF. Then we have FG, EG. The list is done. Okay. The next one will go kind of dot, straight over to a dot, another dot. And off of this one is a loop and a loop. I'm going to call it ABC. List of vertices. A, comma B, comma Z. We have A, B, 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 C, C, C. A to B. B to B. B, C. C, C. Let's go on. Ooh, cool. So we have a graph that has a hook over from, let's call this H, and this is D. This will be R, and we have multiple edges from H to R, as well as a vertex here called C. Multiple edges from H to C. Okay, we list all of the dots as the vertices. So R, C, H, D. And then let's go this way with RH, RH. See, so we've gotten those multiple edges. Let's do HC, HC, HD. And we're good. Next one. It goes from A to B. And we'll have a loop, and inside is a loop, and up here is a loop. Okay, the dots that are labeled are A and B. So those are our vertices. Edges. Let's go take care of the first outer loop, AA, and do another AA. Then we'll go A to B. Oops, no comma. They're next to each other. So AB as a pair. And BB. Okay, the next graph is kind of big. Let's draw it on the side. It goes over here to here, like a big kind of X like this. And that side connects off of this. Let's do a loop. And then there's a point to the side where we could some multiple edges. Cool. This is called L, M, I, K, J. So we need to put down the dots L, I, M, J, K. And I kind of want to go top to bottom for these edges. So starting with the loop LL, and then L goes to M, and L goes to K. Let's go here. I, M, I, K. And I'm going to go across this time. Just use this vertex and check it. Did I get ML? Yes, it's right there. Do I have MI? Yep, it's right there. So let's now go down to K. K goes to I, which is in the list. K goes to L, and that's already over there too. So let's take K to J, and also another one, KJ. I think we're done because now we're at the bottom and there's J, which went to K twice. So we will move into some more notes. Sweet. All right, so today we're also going to introduce degree. Any questions though, or concerns? The degree of a graph is the number of edges that, the degree of a vertex is the number of edges that meet at that vertex. I'll have an example. So let's have this graph. Let's make a small graph that goes from this dot out to here, 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 and this one will go over here. So sometimes it helps to make an extra mark next to the dot right on the edge to help count the degree. So this one has 1 line, 2 lines, 3 lines. So this is degree 3, which we're going to put in parentheses. Okay, this dot has 1 line, so it's degree 1. this dot has one line connected to it. So its first is a degree of 1. Okay, this dot or vertex has 2 lines that connect to it. So its degree is 2. Okay, here there's only one line connected, so the degree is 1. Okay, so next note is that a loop contributes 2 to the degree of a vertex. So let's draw a new graph. Cool, so let's do here. We definitely want to talk about a loop. Go up here and let's do this. Okay. So this would be a degree of 1, 2, 3. You get 2 from the loop and then 1 from that edge right there. This vertex has 2 lines connected, so the degree is 2. Right there and right there. Let's go here. There's only 1 line connected to that vertex, so the degree is 1. Same with this spot. Only 1 line connects to that side. Okay, so off of that vertex, there's 1, 2, 3, 4, 5 edges or connections. So the degree is 5. It's fine. So it would be 1, 2, 3, 4, 5. Okay, and the last thing is just a bit of notation. So let's draw a graph that has like labeled vertices and talk about its degree. Okay, cool. Let's do this one, but we don't have to go crazy. Let's go. L to M. Let's go this way, and we'll loop. And call that good. This is LMP. So we want to talk about some notation. We're going to say degree M like this. And then finds the degree. So this one has 2 connections, so its degree is 2. The degree of L is written DEG parentheses L. Degree of L is 1. There's only one line connected right there. All right, over here, the degree of P is equal to, so with 1, 2, 3. And then more examples. So that's the end of like vocab for today. We just need to practice. Some of the graphs I drew are crazy, so let's try to draw. This first one is not so bad. Cool. So we're going to start with a graph with no labels. We're just going to put the degree on the side. So we go from this vertex down, up, loop. There's a bit more. Go off to this side and up. So that's the graph. And for this part, we're just going to put the degree as a label. So this degree is 1. Let's go here. This degree is 1, 2, 3. Here we go. 1, 2, 3, 4. Degree 4. And that's 1, 2 connections, degree 2. Okay. All right, I think we're ready. So the next graph starts at D, swoops a bit over to something called X. And then we're going to arch like that. And loop, loop, dot. Calls this R. This is H. So we will find degree of D, degree of X, degree R, degree H. Okay, D has 2 edges connected, so its degree is 2. X also has degree 2. 1, 2. R, we're going to have 1, 2, 3, 4 connections, so its degree is 4. And we're at H, which has two edges connected. This is just a boundary. Notes. Oh, I have a comment. Okay, let's see. Oh, cool. The pictures, yeah. All right, my next graph is messy. I think we'll try to draw it and then we'll call that it for today. Okay, let's see. All right, so this is the last graph and then we'll say goodbye afterwards. And we're gonna go, yeesh, it goes S with two loops. And it goes down like that. Okay. Let's piece this together. So just a bit below where that vertex S is, it's gonna go straight across with N and T. This is called G. This is L. And over here is A. So A goes to T and G. L, we already have connected to S. It also connects to N and T. G goes to S, T, and A. G goes to S, G goes over here to T. And we already had G connected to A. This is in the graph. That part looks cool. I think we have everything that's in my notes. Okay. Let's find the degree of G. Let's just look here. Degree G and degree N. Degree S. Degree T. Degree A.
Does T go to G and L?
T goes to G, yes, and T goes to L. And N and A.
Thank you.
Cool. And last one is L, degree L at the end. That's a capital G, actually. Cool. So let's get through this. Starting at S, which looks crazy, but it's got 1, 2, 3, 4, 5, 6. And I also have an answer key, which let's go ahead and be sure. Okay. That was S. Cool. Oh, that was supposed to be for S. Yikes. So S has degree 6. Cool. Now let's find the degree. Let's go for the degree of G. Right there. There are 1, 2, 3 edges connected to G, which makes this degree 3. N is right here. Its degree is 2. Let's find T. We have 1, 2, 3, 4 connections. A is degree 2. And L is degree 1, 2, 3. Okay, I think that's good for today. So we will work on more examples for degree next time. And I will work on making your homework today, but it'll definitely be done by Thursday.